everyone. Our topic for today is about arc length. At the end of this lesson, you should be able to find the arc length of a space curve. What is arc length? The formula for the arc length of a plane curve has a natural extension to a smooth curve in space as stated in the next theorem. According to this theorem, if C is a smooth curve given by this vector valued function r of t, which is equal to x of ti plus y of tj plus z of tk on a closed interval ab, then the arc length of the curve C on that interval is defined using this equation. So the arc length S is equal to the integral of the square root of the square of the first derivative of x of t plus the square of the first derivative of y of t plus the square of the first derivative of c of t dt, where t is from a to b. But this is also equal to the integral of the magnitude of r prime of t dt, where t is from a to b. Okay, so as an example, suppose we are asked to find the length of the curve, of this curve, from t equals 0 to t equals 2. So the first thing that you have to do is you have to define the parametric equations of the components of this vector valued function. Okay, the x component of r of t is x equals t. For the y component, y equals 4 over 3, t raised to 3 over 2. And for the c component, c is equal to 1/2 t squared. And then from t equals 0 to 2 equals 2, we need to find the corresponding x, y, and z coordinates. So at t is equal to 0 by substitution, so your x is 0, your y is also 0, and your z coordinates is also equal to 0. When t is equal to 2 by substitution, so x is also 2, your y coordinate is 4 over 3, 2 raised to 3 halves, but 2 cubed is 8, and square root of 2 is 2 square root of 2 times 4. So we have 8 square root of 2 all over 3. For the c coordinates, by substitution, you have 1/2 times t squared, but because t is 2, so 2 squared is 4, divided by 2 is 2. So this is the arc length with initial point at 0, 0, 0, and terminal point at 2, 8 square root of 2 all over 3, and 2. So our aim here is to find the arc length from this point to this point. So to find the length of an arc, now we need to get the derivative of each component of r of t. Okay, from the given curve, x of t is t, the y component y of t is 4 over 3, t raised to 3 halves. And for the z component, c of t is 1/2 t squared. So we have to take the derivative of each of these components. So x prime of t is 1, y prime of t is 4 over 3 times 3 over 2. But 4 over 3 times 3 over 2 is 2. So we have 2t raised to 3 halves minus 2 over 2, or 1 is 1/2. So we have 2t raised to 1/2 as the first derivative of y of t. Then for the c components, the first derivative is 1/2 times 2t, cancel out 2, so you have t. And then from the formula of the length of an arc, S is equal to the integral of the square root of the square of the first derivative of the x component plus the square of the derivative of the second component plus the square of the derivative of the z component, where t is from 0 to 2. So by substitution, x prime of t is 1, y prime of t is 2t raised to 1/2. So when you take the square, so that's 4t, plus the square of the first derivative of c of t, which is t squared, times dt, where t is from 0 to 2. And then by completing the square, we have to transform this to perfect square trinomial by taking the half of the middle term. The half of this is 2, so when you take the square is 4. So to make it a perfect square trinomial, the constant term should be 4. But because this is 1, so we have to add and subtract by 3. So this can now be written as, sorry. So this can now be written as t squared plus 4t plus 4 minus 3. And then by factoring, so this is now factorable. The factors are of this form, t plus 2 to the second power minus 3 dt. And then you let your u be as t plus 2 and a here as a square root of 3. So a squared is 3. And then using this formula, the integral of u squared minus a squared du is u over a square root of u squared minus a squared minus a squared over 2 times the natural log of u plus the square root of u squared minus a squared. So following this formula, which is u over a, your u is t plus 2 divided by divided by 2 times the square root of u squared. So this is your u squared minus a squared. So t plus 2 quantity raised to the second power minus 3. And then minus, this is a squared over 2, but a squared is 3. So 3 over 2 natural log of u, where u is t plus 2 plus the square root of u squared minus a squared, which is square root of t plus 2 to the second power minus 3, where t is from 0 to 2. And then by substitution, if t is 2, then I have 2 plus 2 is 4 divided by 2 is 2 times the square root of 2 plus 2 is 4. So 4 squared, 2 plus 2 is 4. 4 squared is 16 minus 3, so you have 13. Okay, so you have 2 square root of 13 minus 3 over 2 times the natural log of t, where t is 2 here. So 2 plus 2 is 4 plus, this is 2 plus 2 is 4. So 4 squared minus 3 is 13. So we have square root of 13 minus, so if your t is 0, so 0 plus 2 is 2 divided by 2 is 1. Times this is 0 plus 2 is 2, 2 squared is 4, minus 3 is 1, so square root of 1 is 1, times 1, so we have 1. Then minus minus, so this becomes plus 3 over 2 natural log of, if t is 0, so 0 plus 2 is 2, plus this is 1, and 2 plus 1 is 3. So using your calculator, this is approximately equal to 4.816. Okay, so in summary, to find the length of an arc or the arc length of a space curve, the formula is equal to the integral of the square root of the sum of the square of the derivative of each component. So you have square of x prime of t plus square of y prime of t plus the square of c prime of t dt, where t is from a to b. Or in simplest form, this is just the magnitude of the derivative of r of t dt, where t is from a to b.